Hello everyone. This project was part of an IoT course at the University of Oulu. Its main goal was to establish an IoT system that could collect temperature, atmospheric pressure, and lux level data from a remote, low-end device. The collected data would be sent to the cloud for storage, processing, and visualization. Before starting your project, make sure you have all the required tools and software ready in place. You need to have a FIT IOT-LAB account, RIOT OS, and an AWS IoT account. We strongly recommend that you read the contents of the README file before you proceed. Let's get started. Step 1. Connect to the SSH front end of the Grenoble site of FIT IOT-LAB by using your FIT account. After sign in, clone the RIOT OS repository to your local environment. This may take few minutes. This project is divided into 3 main layers. The main objective is to achieve the maximum efficiency, power consumption, and reliability of each layer. Layers are Sensing Layer, Network Layer, Data Management and Visualization using AWS. In this implementation, we use the FIT IOT-LAB M3 microcontroller to capture data on temperature, atmospheric pressure, and lux levels. And also we are using AWS IoT-Core to store and visualize the data. We decided to use the MQTT/MQTT-SN protocol. MQTT stands for Message Queuing Telemetry Transport and was built by IBM. It is a lightweight and widely adopted messaging protocol specially designed for low-power IoT devices. Step 2. Download the folder IoT Mini Project 1. Step 3. Submit an experiment in FIT IOT-LAB Grenoble site. Wait a few minutes to start the nodes. Step 4. Build the GNRC border router firmware and use the CLI tools to flash to one of M3 boards. In our case we use M3-100. In our project, we used a broader router to extend public IPv6 addresses throughout the local network, making it easier for the FIT IOT-LAB M3 sensor node to connect with AWS services. For this purpose, we utilize the border router example provided by FIT IOT-LAB, setting up a dedicated FIT IOT-LAB M3 board for the border router configuration. Now you can configure the network of the border router on M3-100 and propagate an IPv6 prefix with ethos_upt.py. Step 5. Now, in another terminal, SSH to the Grenoble front end and build the sensor firmware and use the CLI tools to flash to M3101 node. After successfully downloading the firmware, use Netcat tools to access the node M3101 shell. Use help to see all shell commands. You will locate the ifconfig command. Please use it to confirm that the global address has been successfully distributed to our M3101 node from the border router. If you see a global address, the propagation was successful and now you should have access to the internet. Step 6. In another terminal, log on to the remaining A8 node, node A8103. Use vimconfig.conference to open a configuration file and copy and paste the configuration given. This will allow us to listen to the MQTT clients on the network from port 1885. Open a Vim configuration file and copy and paste the configuration given. Obtain the global address of the A8103 node. This will need to start the communication with the M3101 node. Now open the M3101 terminal and start the MQTTS client. Step 7. Download and install the AWS IoT Device SDK for Python. After AWS installation, clone the IoT Mini Project 1 to the A8103 to start the MQTT server. Step 8. Before you proceed, please ensure that you have AWS IoT certificates. For more information, please refer to the AWS section. Once you have downloaded the certificates from the Amazon IoT-Core website, store them in your personal Git repository for easy access when needed. Now open the spridge.py file using vim idiot and set the path and the certification names. Once all is completed, start the Python server. You will see data transmission stat. If you successfully execute the above steps, you will see that data is received by your Amazon IoT Core. Well done. Now let's process and visualize data using AWS tools.
Now I will show how the data visualization was done using AWS. Firstly, head over to the MQTT test client in AWS IoT Core. Enter your desired topic. In my case, I am using sensor/station1. Then click on subscribe. And now you can observe the incoming data. To visualize this data, navigate to message routing and then rules. This is the SQL statement to select all data from the topic. Upon receiving data, set the action to send data to Amazon timestream table, which acts as the database. Moving on to the Amazon Managed Grafana, we created the workspace. You can access the Grafana environment by clicking on Grafana workspace URL. Inside Grafana, it displays real-time temperature and pressure data streaming in from IoT devices. And also we have set up notification system. In the rules, if the temperature exceeds 45 degrees Celsius, it triggers two actions. First one is A push notification is sent to an SNS, and then data is sent to the DynamoDB. This is the SNS where we have created the topic for notifications. Email are sent to the specified address, and if need, you can send message by adding a phone number also. These are the notifications that received when the temperature is higher than 45 degrees Celsius. Thank you.